So, my dear friends, we are right now in transmission line protection using overcurrent and earth fault relays. We have completed 5 sessions and we have seen how you can set the relay using overcurrent relay, phase relay, not earth fault relay. We have yet to see. But an overcurrent relay, how you can set using the data and using the time current discrimination. That is, the relays we use are IDMT over current relays. But in IDMT over current relays also there are 17 different types of characteristics. Let us not talk about all 17 right now because it would be too much, but at least 4 very important characteristic: normal, inverse, IDMT, very inverse IDMT, extremely inverse IDMT, and long time inverse IDMT. So these characteristics have their own significance and have their own applications. So in this session number 6, we will see the problems faced by normal inverse IDMT over current relays and what are the probable solutions to that. So the first problem is ZS by ZL ratio, right? We have already discussed that IF, fault current, is E upon, that is induced EMF by generator, upon ZS by ZL. ZS is the impedance from source up to relaying point and ZL is the impedance of relay to fault. And if we consider the whole line that is protected, then relay to the end of the line. But if ZS by ZL is very large, see, ZS may be very large with reference to ZL in 2 cases. That is, ZS is very large and another ZL is very small. That is also the another possibility. So first possibility, let us take. So in first possibility, if I take for relay R1, ZS is small. Relay R2, ZS is large because from source to relay R2. But for R3, it is very large. So ZL is so small with reference to ZS that you can ignore ZL with reference to ZS. So the fault current will be practically equal to E upon ZS. So for fault F1, that is just after relaying point R3, and for fault F2 at the end of the line CD, fault current is more or less equal to E upon ZS, means more or less constant or insignificantly different. So time of operation also is insignificantly different, and therefore the use of or application of normal inverse IDMT over current relay is not justified. That is our first problem in normal inverse IDMT over current relays, that we cannot justify the normal inverse. And therefore, people have found out, the engineers have found out the another kind of characteristic, that is very inverse and the extremely inverse. If you can see in the figure, you see the number 1 is normal inverse, number 2 is very inverse, and number 3 is extremely inverse. Number 4 is fuse or MCCB characteristic. That is usually the case. No, what we are seeing, we are seeing R1, R2, R3, and then beyond D there is fuse or MCCB. So R3 is to be coordinated with that fuse or MCCB. So if you see the characteristics are number one, normal inverse. So normal inverse you take, I am taking 2 PSM, flux ring multiplier, 3 and 5. You can see 5 and 3 for normal inverse. 5 and 3. Let me check if I have written 3 and 5 only. Yes, PSM 4 and 5. I'm sorry. PSM 4 and 5, very near. PSM 4 and 5. If you take PSM 4 and 5, then for normal inverse, the time difference is 0.707 seconds. Time difference is, you see, 0.707 seconds. For 4, it is coming here, and 5, it is going there, 0.707 seconds. So, time difference is very small, negligible. So, normal inverse is just justified. You could have used definite time. But should you use very inverse in the same case for same difference of current PSM 4 and 5? The difference is 1.125. And if you use extremely inverse, yet steeper, the difference is only steepness. Relay construction is more or less same, but the difference is in the steepness, 1.125 second. That is for extremely inverse, the difference is 1.125 second. Sorry, that the difference is 2 seconds. So difference is more. Difference is more. That is, the characteristic is now justified for the same system. For the same power system, the difference is more for extremely inverse relay. Another difference which you can see is the extremely inverse characteristic best matches with the MCCB characteristics. So protection offered, the coordination offered is the best if you go for extremely inverse, because after extremely inverse there is a fuse. So R3 that we are seeing here, that would be better if you use extremely inverse. So the first problem is ZS by ZL ratio, and the solution is to use very inverse or extremely inverse characteristics. The another problem in the use of the normal inverse IDMT or current relays is varying generating conditions. Or for any relay, this is the problem. Varying generating conditions means at night the load is less, so you are reducing the generation. And because you are reducing the generation, the load has reduced, so you are reducing the generation. So at night when fault occurs, the fault current has a less value because ZS has increased, number of generators have reduced, therefore the fault current is less. And in the extreme case, it can so happen that fault current at night time will be less than the maximum load current at daytime. So when this occurs, you cannot set the simple overcurrent relay, because if you set for fault current, then the generator will trip. I mean, then the line will trip for normal current at daytime. And if you set for load current, then it will not trip for fault at night. One may probably argue that if fault current is less, that there is not going to be any damage to the equipment, because if higher load current can be taken by the equipment, lower fault current can easily be taken. But it is not so, because there are many reasons. One reason is that at the point of fault, voltage is dropped. Voltage drops to practically zero. So people after fault, the consumers after fault are not fed by electricity. That is wrong. Another thing is that when fault occurs, that is asymmetrical fault, double line to ground to line to ground, then there are NPS currents present, negative phase sequence current. Negative phase sequence current has a rotating magnetic field rotating in reverse direction to positive. And therefore, in all dynamic machines, the slip will change. You see, slip normally for synchronous generator or synchronous motor is 0, but for negative phase sequence, slip will be 200%. So, double frequency rotor eddy currents will flow in rotor iron, and it can make the rotor iron red hot also if it flows for more time. And if it so happens, then it will damage the insulation of the generator. However, the fault current is less than load current. It is generally said that the uh, heat that is generated by positive sequence current is H I1 square RT. Then heat that is produced due to same amount of negative sequence current is 6 times that of positive sequence current. So damage is 6 times. Other way telling, I can tell that if 12 ampere of positive sequence current flows, H heat is developed. Same H heat will develop for 2 ampere of negative sequence current, just 6 times less. So negative sequence currents are harmful, and therefore even if the fault current is less than the load current, it is harmful. Third, for double line to ground and line to ground, the zero sequence currents will flow. Zero sequence current, we have seen that it is third harmonic current. And third harmonic current means eddy current losses are proportional to frequency square. So they will be 9 times. So once again, heavy amount of heat will develop. Eddy current losses will increase and losses will increase. And all dynamic machines and even transformer will be overheated. So less fault current cannot be allowed. You have to sense it. So the problem is how to sense the less amount of load current, uh, less amount of fault current than load current. So in the relaying world, a voltage controlled overcurrent relay is available. This relay automatically changes its plug setting to 40% of set value if the voltage collapses below 70% of the rated voltage. When normal load current is passing, the voltage is normal. But when fault occurs, voltage is going to collapse badly. And therefore, the plug setting will automatically reduce to 40% of set value. I am not going into the constructions. You see, electromagnetic relay also such construction is available. I should say was available because they are now not produced. They are now not manufactured. In static relay also it is very easy that you can attach the uh, plug setting with voltage. And in numerical relay also such thing is possible by AND logic. You see, under voltage relay and overcurrent relay, you can do the AND logic. So that is possible in all the 3 types of relays. If you do so, then when fault occurs, fault current is low, but then your plug setting also is reduced. So there are 2 characteristics. One is fault characteristic and another is load characteristic. Load characteristic will be useful for overloads and fault characteristics will be used for faults. So that is shown in that figure. I have not shown here. Probably there are two types of uh, characteristics. I mean, there will be 2 curves. One will be lower curve, one will be higher curve. But if you see by chance your voltage control relay is not available with you, You can use two relays. One is simple overcurrent relay 51 and another simple under voltage relay 27. I will set 51 for normal load current at daytime maximum load current, and 27 I will set at 70%. That means if the voltage reduces below 70%, the relay will de-energize. Try to understand. Relay will de-energize. So if you see so, the circuitry can be read like this. At daytime, you set the relay for daytime load current. So 51 1 will close. In circuitry, you have to show all relays in de-energized condition. Therefore, it is shown de-energized. But it will close. But 27 1 will remain open because it is energized, because your voltage is normal. So 86 cannot energize and breaker cannot trip. My purpose is served because at load current, breaker should not energize. When fault occurs at night, it is less than load current, so 51 1 will certainly close and voltage has collapsed. Therefore, 27 1, that is the under voltage relay will de-energize. 27 1 will also close. 86 will be energized and breaker will trip the line when the fault occurs. Fault current is less than load current. Even then, the breaker will trip as desired. This is known as monitoring of the overcurrent relay by an undervoltage relay. So these two basic difficulties are there in IDMT relays, normal universe IDMT relays, and they can be solved like this in the relaying world, right? So we have done one example. We have seen the difficulties. So in the next session, session 7 of IDMT, I mean transmission line protection by overcurrent relay, we will go to earth fault schemes. How do we set the earth fault relays? The philosophy of setting the earth fault relay is different. However, the construction of both the relays, earth fault relay and overcurrent relay, is same, but the philosophies are different, and therefore we have to see that philosophy, we have to learn that philosophy. Therefore, we'll see that in session 7. For today, my friend, my talk ends. I do not keep long talks. I'm very happy and getting amazed by seeing that I'm getting likes from many corners of the world. Probably all corners are now covered. My students will certainly like my video. But my dear friends, likes do not earn me the uh, the view hours. You have to hear the whole video. And I can assure you that the person who is very experienced, 22 years experienced, 25 years experienced, he will get at least 5% more knowledge from my videos. Because you see, when persons are experienced, he is doing in one corner, one field. Complete picture is not with him. So this videos will give him complete picture of protection. And if such problem occurs, it will be useful to him. So the experienced person will get 5 to 10% of knowledge. But the persons who are not at all experienced, persons who are uh, learning the subject fresh, they will know 100% knowledge. They will know very good knowledge. This is what is done in the field. But because this is tough, the subject of protection is quite difficult. And therefore, you see, I had published the book in 2010. One renowned publisher had published the book, but now they have withdrawn because students are not purchasing. Probably faculties are also not understanding. So if students ask, faculties find it difficult to reply. because the subject is difficult. Those people who have learned the subject under me at BVM for 26 years, have taught about 1600 students. They know the subject well. And when they go through this video, they tell me that we refresh our old days, right? So they know, but otherwise the subject for other universities is difficult, and therefore the simpler book is now being promoted by the same publisher. So, but unfortunately, that simpler book, uh, what it gives to the people is not in the field. The field is what I am talking about. The practice is this, and you will come across this. Students at Nirma and PDPU, when I'm teaching, they are not listening at all, because they say that what about protection? They're going to go to foreign countries and learn computer science. But some students go to Tata Power, some students go to Siemens, some students go to Adani, and then their boss asks him a question, and then they remember me. While studying, they did not hear me, because they did not find it important. But when the problem comes, real problem comes in the field, they remember me. Because then they remember that Oza Sahab must be knowing the uh, solution to the problem. Rather than that, I don't mind answering. I am answering. Every week I am getting one problem from my old students. That old students and some old friends, by some way they have come in my contact, so they do contact me and ask me the difficulty. So often the difficulty cannot be answered directly. I have to ask them to send their single line diagram of their company, of their factory, and based on single line diagram, I do give them solutions. But if you hear this video, these are free of cost. eh? And if one person hears the video for half an hour, because each video is just of half an hour, then I earn zero point 0.5, so to say, view hour. And in YouTube, first milestone is at 4,000 view hours. I have reached about 1,000 viewers. I have to reach 4 times the viewers. If 8,000 engineers hear the video fully for half an hour, then I will earn 4,000. But there are not 8,000 engineers. There are about 80,000 or 8 lakhs or 8 million engineers in the world. I should earn not 4,000, but 4 million or 40 million viewers, you see. But unfortunately, it has stopped only at, I should not say it has stopped. It has started from 70, 60, 50, 100, and it has reached up to 1,000. So I am very happy that you like my videos. But rather than liking, you do like, that is also appreciated. But then you hear also the whole video. You see, that will earn me view hours. So I would request you all that you please read through, hear through the whole video. You will get at least 5 to 10% more knowledge. And you share to 100 friends of yours, engineers. And if they hear, then only I will earn the viewers. So stay tuned with Idmt. Idmt is going to give you about 70 to 80 videos. I have reached up to 50. Still more, 20 to 30 videos are online, because I have to talk about uh, induction motor protection. I have to talk about transformer protection. I have to talk about bus zone protection. I have to talk about protective CTs and PTs, at least this much. Circuit breakers, probably I may shift to the another, uh, I mean, there will be another course of circuit breakers. But this course on power system protection will give you about 70 videos of half an hour. So 70 videos of half an hour will, if one person hears 70 videos, then I'll earn 35 view hours, right? And if 100 persons or 200 persons or 300 persons or 1000 persons hear the videos, I will cross much more than 4,000 and free of cost. You have to simply hear, right? And it is not useless. You are gaining knowledge through that, because I am sure and certain, because I am getting the feedback from many people, not only from India, but from different countries also, that they have not learned these things in universities. These things are not taught in university. Reason unknown. Reason I don't know. This is required in field, but universities are not teaching. The engineering colleges are not teaching. This is exactly what is required in the field, but not taught. So this is being taught free of cost, available on YouTube. So please, please read through the whole video. Till then, my friends, thank you so much. Thank you for patient hearing and good day.